Highlander here, welcome. Today we're going to look at the tools that you need to program anything after you've designed your software and you've done all the thinking and trying out in your head. At some point you're going to have to want to sit down and code something. So you need stuff to do that. And the things you need are an editor. You need the compiler, and you need tools like debuggers. There's a lot of other stuff that you can find, but these are the tools that are really essential. Now, the thing is, it's not clear what you should use. That's because it's a very personal choice. The tools that you are using are geared to your workflow as a programmer, and there's one thing that's really essential that I kind of want to show you. So I'm going to use a whiteboard to make some drawings, right? It'll be fun. So as a programmer, the most important thing that you'll use is an editor. So draw a little thing, and in that phase you'll be in an editor and you'll be typing in your code. Now there's all kinds of tools that are necessary there. We'll talk about that later. But after you've done your editing and you've saved your file, you're going to have to compile your software. This is assuming that we're programming C++, of course, and that we have actually something to compile. This phase is called compiling because we're actually translating code into executable code for the computer. If we were writing assembly, then this compile phase would be called assemble. If we were using a scripting language, we wouldn't even need to compile because we can just run the scripted language. But the compile phase in our workflow is essential. Now, most programs that you'll program are probably going to be quite quick to compile. But in some programs, the compilation phase can take a long time. You know, if you have really big programs, then the compile phase can be really long. And even something that is 5 minutes long can be can seem very long if you have it, you know, if you have to do it 5 times a day or 10 times a day or whatever. After compile, you're going to have to want to run your program and possibly, we'll just run it. You know, we'll just run it. And then when you run it and there are errors or whatever, of course, you're not hoping for errors. You're hoping that everything will be fine, but you'll be going back to the edit phase because you'll be debugging. So you're going from edit to compile, and you're going from compile to run. Now, the reason why this is important is you don't want to, after you save your file, have to go to a command line, change the directory, and type in a compile command. And then after it's compiled, you don't want to have to copy your executable or rename it and then moving it to another directory and then going to an environment where you can run every step that is in between these blocks is one too many, because this is a loop that you'll be going through many times, and it's going to be very irritating to have time in between these phases. So this is what an integrated development environment does for you, among other things, is to knit these together so that you can just, in the editor, press a button and it'll compile and it'll take care of all the environment settings. It'll do the compile. It'll even the build steps required for making your software can be pretty complicated as well. You know, we'll all see that later, but even in a single file program, it's just very comfortable to have everything set up so that the compile works, that it can find all the header files, it can find all the libraries. Then it will link everything into an executable, because after compile, you can't just run it. You'll have an object file. It'll have to be linked with all the libraries, and then it'll have to exist somewhere where you can run it. You know, if you could just press a button and run the software, or it does that automatically, that's such a comfort to have, right? So this is what we're looking for in an environment that'll help you develop. Now, in the debug phase, you can just run your software, but you can also run it in a debugger that will allow you to stop the software at any point, and you can walk through your code. You can inspect the values of variables at certain points so that you can be sure that what you've programmed is actually what you get. And then stopping the debug cycle and going back to edit. That should all be one nice and comfortable loop. So whatever it is that you choose, it has to be available on your platform, which is the most important thing. And there's many choices, and people have many different preferences. I've seen editors that just irritate me so much that I can't get used to the keys, and I've met other people who are very enthusiastic about whatever it is. Myself, I like to use VI, which for a lot of people is just too cryptic to use. For simple tasks, I like to use VI to do something quickly. It has to be easy to install. It has to be easy to upgrade. Everything has to work together well. And, you know, if it's... it would be nice if it doesn't cost too much. It can be smart to invest in an editor, maybe even in a compiler, although most compilers are available for free. Now, if we look at editors, and these are just some of them are really bare bones editors, some of them have integrated features. But just an example, if you Google for editors, you can find Emacs, which is a well-known one, Atom, Visual Studio Code, which is the one we'll be installing in this video, Sublime Text, which has build features, but you'll quickly see that Sublime wasn't made to actually build software, but it can do it. There's brackets, there's Eclipse. Eclipse is a very, very extensive environment where you can build many different things with it, not just code, but you can build an environment to build your code in. It's very advanced. I don't like it personally. There's Notepad++, and of course there's VI, or the Vim version, which also has a graphical side. VI being the quintessential text editor that came with every Unix system. Now, when we talk about C++ compilers, everybody knows the Microsoft C++ compiler, the GNU G++ compiler, which is prevalent on many Linux machines. But there's a load of C++ compilers around on platforms that you may not even have heard of, and they all support or don't support certain things. I've just Googled them. You can find them. This list that I've shown here isn't complete, but looking for compilers is you can have a lot of fun finding a compiler that is right for you. Sometimes compilers don't support things that you want. They don't support an optimization you want. Maybe there's a certain library that doesn't compile on it very well, or that isn't supported anymore. So usually you won't have a lot of problems selecting one. You're pretty safe selecting the Microsoft Windows compiler. But if you're not on Windows, then you'll have to pick something else. So for this choice, don't spend too much time on it until you run into a specific problem, because every C++ compiler will at least support some standard of C++. So whatever it is you choose, whatever it is good for you, figure out how that works. There are probably many examples of how to get stuff to work. It can be a bit of trouble, but usually it's not too complex to figure out. What I'm going to do, at least, is use Microsoft Visual Studio Code because it's free. It is feature-rich, and most people will probably have access to it or will want to use it, or maybe use it already. I want to show how to use it for C++ in our use case. It's a lightweight solution, and the other side of the story, which is what I eventually intend to use, is the Microsoft Visual Studio environment to have everything in one package, and I'll show you why that is as well. Neither is better or worse than the other. Again, it's personal choice. So let's start with installing Visual Code. I just Googled Microsoft Visual Code, and you get this. So I'm going to download for Windows the stable build. And there we go. Let's see if I can put it here somewhere. Okay, there it is. And I'm going to run it. Accept the agreement. Of course, we've read all that. It wants to install this into my user profile, but I don't want that. So I'm going to... Wait a minute. Yeah, I'm going to change that into this. Next. Visual Code. Let's create a desktop icon and press install. Okay, finish. When we start, we get something like this. Actually, I have a little C++ code that I borrowed from the one lone coder. And let's see what happens if I open this up. So this has some C++ in it. So it already does something, which is good. I mean, I'm getting some syntax highlighting, but it's already saying that the C or C++ extension is recommended for this file type. So I'm going to show the recommendations. And it's got two of them. It's got this one, and it's got this one. This is by Microsoft. Right? This is the Microsoft IntelliSense Debugging and Code Browsing. So I'm going to install this as well. Still, I'm getting a problem here. Include errors. Please update your include path. This code I didn't write. This is the code by one lone coder that I thought would be a nice bit of code to start with, just to test if things work, you know, if I've done things correctly. And apparently, simply coding, installing Visual Studio Code doesn't do it, because I've got include errors. Well, one of the things that you have to remind yourself of is that we just have an editor, and we don't have a development environment yet. So what I'm going to have to do is to install the actual compiler. And hopefully that will help me set up the include path. So I'm going to close this, and I'm going to install a compiler. So I look for the Microsoft C++ build tools, and I come to this page because the Microsoft C++ build tools allow me to have compiling a native C++ program on the command line, which is basically what I want. So I download the build tools. It uses the Visual Studio installer to do things. So I'm going to click continue. It's going to download stuff. Okay, so what do we want? We want the C++ build tools. And I basically don't want anything. I don't want to have the .NET stuff or the Node.js or data store, Azure, Universal Windows Platform builds. No, I just want this. Now, on the right side, I can see Microsoft Visual C build tools. This is the Windows 10 software development kit. Headers, libraries, and tools for developing apps that run on Windows operating systems. Well, I might want that. CMake, testing tools, address sanitizer. I'm just going to leave that default. Okay, so the installation's done. As an aside here, I thought this was nice to see. This is some developer news, and they're saying here that they've been working on implementing C++ 20 features. So that's not even accepted. So that's nice. So now let's start Visual Studio Code again. Okay, well, it's apparently it's worked. So I'm gonna try to build it. I suppose I run without debugging. Control F5. Yeah. Let's say Windows. cl.exe build and debug active file. Oh, okay. cl.exe build debug is only usable when VS Code is run from the developer command prompt for VS. Now that is crucial. So installing this doesn't really make a development environment automatically. So it took me a while to figure out why this was happening, but when we installed the build tools, what actually happened is that Visual Studio also installed these files. This is the developer command prompt. So we'll just click this, and a little box opens, and I can go to my directory where my code is. Here's my code. What this box has done is that it has set up my environment variables correctly so that code can find all the files that it needs. So if I type in code and a dot meaning the current directory, it'll start Visual Code again, but now with all the correct settings. So essentially, let's see if I can I open up a terminal? A new terminal. Right. This puts me there. If I look at the directory now, there's these files. If I go to run without debugging, and I'll just say Windows, and I'll just type that, will it run? Oh yeah, it's going. It's done something. And we can see that it has generated an executable here. And there it is. There it is. If you don't know about this software, this little program procedurally generates a consistent universe, and all these dots that you see flying around, they represent a planet, and this planet has moons around it. And the thing is that I can move around, and this is all generated randomly, and if I go back to the same place, if I remembered where that was, I would find that it generates the same universe every time I go to the same coordinate. So that is pretty impressive. But we've made it work. The only thing that we have to remember is that we can't just install Visual Studio Code, we have to start it. We have to also install the build tools, and we have to start it from a little terminal console. Now, that being said, this is a good way of working. We have C++, we have an editor that can help us do things. We can compile from here. We can probably debug from here as well. But I really want to also try the integrated development environment, because I don't enjoy having to use this every time I want to start programming. So I'm just going to leave this as it is. Close that. Close that. But I want to install Microsoft Visual Studio, like the real thing. So Visual Studio products, Visual Studio 2019, Windows apps, and I'm going to install the Community 2019 version. So I'm going to save the VS Community one. And I'm going to start that. Now it says Visual Studio installed. Before you get started, we need to set up a few things so that you can configure your installation. Well, I'm going to say continue. And I'm guessing that we've already done one or two things. Okay. So what do we want? ASP.NET, Azure, no, Node, no, Python.NET, desktop development with C++, build modern C++ apps for Windows using tools of your choice. I might want to do that. That will install the just-in-time debugger and profiling tools and test adapter for boost.test. And the Universal Windows Platform development. Create applications for the Universal Windows Platform with C#, Visual Basic, or optionally C++. What does that do? Graphics debugger and GPU profiler for DirectX. That sounds interesting. This does the core editor, desktop development, right, IntelliCode, blend for Visual Studio. Blend for Visual Studio, wow. That's a lot. I can see why this is big. This needs 17 gigs now. Universal Windows Platform Tools, Windows 10 SDK, Graphics Debugger, IntelliCode. I'm guessing we're not going to need this right away, but... oh, wait a minute. I actually have to choose, do I? No, I don't. So I've picked these two, but I could also not do this and then add it later. I'm going to change the installation directory. Okay, it's running. Let's wait for it to end. It has to be said, though, that the Microsoft Visual C++ compiler is one of the ones that has the most support, the most actual and recent support. When C++ was still developing and growing, at one point the standard template libraries were added to it. And the support for the standard template libraries, which we'll go into the details in a later video, but the support was iffy across all of the compilers. Some just didn't do a very good job, and many dropped their support. And even though the current support from C++ is for the standard template library is based on a library that was not created by them, it is at least still actual and being actively developed on. So, all right, so the installation is done, and it wants me to authenticate across all Azure Active Directories on sign-in. Okay, so that seems to have worked. This is my login live account. Okay, so let's do this. What we have to do to test this out is basically we have to create a solution. And all we have is the C++ source code and the header file that goes with it. That's what we have. Now, if we just open that file, we won't be able to compile it or do anything with it because it's not a solution. So what we have to do is create a new project, which is what we're doing. And we want to create a console application. So we click Next. Now we have to give it a name. Now it helps to give it the same name as the proc gen universe. So that's what we're going to call it, right? Proc gen universe for procedurally generated universe. The location is the repository proc gen universe. Let's check that. Is that good? No. D repository OLC proc gen universe. That's the folder. And that's the project name. And we're going to go create. And for some reason, it didn't pick that up. Right. It's made some other file. So we're going to be adding the file that we have. So we're going to add an existing item, which is our procgenuniverse.cpp file. Is that? No, that's not it. That's not it. That's not it. We're going to go to our... That's it. It's created a subfolder. So that's what we want. And that is not this one, but it's that one. So we're going to delete that one, remove that one. Yes, remove completely. So now we have this. And we don't have any executables here yet, right? We have nothing there. So we're going to now go to build and build solution. Now, it's given me some warnings, right? It's saying that we're doing a conversion from double to T, which is some kind of template thing. I don't know, but they look like warnings, and at the end it says build succeeded. So if I look in the folder, it's probably in this one, and then in this one, and then maybe in this one. I don't know. It sort of makes a little puzzle of where... Oh, there's the executable. But if I go now to... Where are we? To start without debugging, I just start the program. There it is. There's our program again. So we've built... Oh, yeah, there it goes. We've built a console application. In Visual Studio. So that's just an example. It does start a console for us. And it's probably a little bit getting used to working with this and setting it up to your own needs. But basically, that's it. It's pretty easy to get started, but I would say that the Microsoft Visual Studio complete environment is quite large and extensive, and is going to take a little getting used to, and maybe it is more than what we need, but it will make sure that you have everything there, and that you don't really have to install anything else. The Visual Studio Code example, it also works. It works just as well, but you have to sort of make an extra step, and that's just what we wanted to prevent, really. So, that's it so far. It's okay to work with anything else that produces an environment that compiles C++ into executable code. So next video, we'll be actually getting into the coding. So I hope you liked it. Thanks for watching. Bye-bye.